Hi students, aromaticity is one of the important topic in which students may have ambiguity. Aromaticity is an important reason for stabilization of organic compounds, and the concept can be interpreted in many ways. So I plan to make two videos on aromaticity. The first part will deal with the basics of the concept, and the second part I am going to discuss some important and interesting questions that are related to aromaticity. Okay, now we know benzene is aromatic. Benzene and its derivatives behave very differently as compared to aliphatic compounds. They show unusual stability and resist addition, oxidation reactions, etc. For example, let us consider these reactions. See here, cyclohexyl chloride undergoes substitution reaction when it is treated with aqueous KOH. So to give cyclohexanol, and if I have a double bond in allylic position, the rate of the reaction increases and the reaction becomes faster. When I have another double bond which is in extended conjugation position, the rate of the reaction increases much more. But if I have one more double bond like this, I expect the rate of the reaction must be much greater than the previous three cases, but to my surprise, the reaction doesn't happen at normal condition. That is because we know there is a partial double bond character between this chlorine and carbon. Okay, so Eric Huckel, he proposed his famous theory on aromaticity. I'm not going to discuss the theory in detail, but I'm going to give you a set of conditions that are essential for aromaticity. These are the essential conditions. The compound must be a ring, or it should have a cyclic structure, and it should have planarity. Planarity means if the molecule is placed on your table, all atoms that are there in the molecule must touch the flat surface. So if it is so, I can call that as a planar molecule. And normally sp2 hybridized carbon or whatever the atom, sp2 hybridized will be a planar molecule, and sometimes sp3 hybridization. If a carbon has carrying negative charge, it will also have planarity because the lone pair of electrons will be there in the orbital which is perpendicular to the plane of the molecule. So that is the second condition. Third one is conjugation. Conjugation can be explained like if your compound has like double bond, single bond, double bond, single bond, double bond, then I can call that as a conjugation. Or else double bond, single bond, double bond, single bond, positive charge. That is also conjugation. Double bond, single bond, double bond, single bond, negative charge. That can also be considered as a conjugation one. Or a double bond, single bond, single bond, a lone pair of electrons. That is also. Or a double bond, single bond, positive charge, then again single bond, and double bond, and again lone pair. Again it is in conjugation. So conjugation is a necessary condition to have ring cyclic, the pi electrons delocalization and ring current. Okay. So if a molecule, then the last rule is 4n plus 2 pi electrons. So n can be 0, 1, 2, 3, anything. Fine. So if a molecule satisfies all the above four conditions, then it will be called as aromatic. Suppose if a molecule satisfies all the first three conditions, but it deviates the fourth condition, that is if it has 4n pi electrons. If it has 4n pi electrons, then it will be called as anti-aromatic. It will be called as anti-aromatic. And if a molecule doesn't satisfy any of the first three conditions, that is, it may not be a cyclic compound, or it may not be a planar one, or it may not have conjugation, any deviation in the first three rules will result in non-aromaticity. So students, let us discuss some interesting cases. Okay, let us see the first one. Here the compound is cyclic but not planar. and it is not in conjugation also. The double bond, single bond, again single bond. Moreover, this carbon is sp3 hybridized. So sp3 hybridized carbon will render the molecule a non-planar one. That's why this molecule is non-aromatic. Okay, let us go to the next one. Now here the compound is cyclic and it is planar. This carbon is now sp2 hybridized and the double bond is in conjugation. See here, double bond, single bond and a positive charge. So it satisfies 4n plus 2 pi electrons rule also. Here n is 0, so 2 pi electrons are there, which means this compound is aromatic. In the third case, the double bond, single bond and negative charge, it is in conjugation. The compound is cyclic and it is planar. Thank God that this carbon is sp3 hybridized. Though it is sp3 hybridized, the electrons present in the compound will be in the orbitals which will be perpendicular to the plane of the plane. That's why this compound is a planar molecule, and the pi electron cloud will be there, and the 4 pi electrons are there. Here 4 pi electrons, which means it deviates 4n plus 2 pi electron rule and it satisfies 4n pi electron. That's why it is anti-aromatic. That's because 4n pi electrons rule. Fine. Go to the next. Let us go to the next one. Here, this carbon and this carbon, these two carbons are sp3 hybridized. That's why the compound will not be a planar one. So it is non-aromatic. In the fifth case, the compound is cyclic and it is planar, but all atoms are sp3 hybridized and the double bond is in conjugation, double bond, single bond, double bond, single bond, but it has 4 pi electrons, which means it deviates 4n plus 2 pi electron rule, so it is anti-aromatic. In the sixth case, this carbon, it is sp3 hybridized. That's why it is non-aromatic. Again, for the same reason, this is sp3 hybridized, so non-aromatic. Okay, in this compound, this carbon is again sp3 hybridized. That's why it is non-planar, non-aromatic. Okay, in this compound, so it is cyclic, planar, and this carbon is sp2 hybridized now. sp2 hybridized, double bond is in conjugation, double bond, single bond, double bond, single bond, positive charge. And 4 pi electrons, 2 plus 2, 4 pi electrons are present, so it deviates 4n plus 2 rule. That's why it is anti-aromatic. Let us see the next case. This compound is cyclic and it is planar, and double bond, single bond, double bond, single bond, negative charge. Conjugation is there, and 2 plus 2 plus 2, totally 6 electrons, which means it satisfies 4n plus 2 pi electron rule. That's why it is aromatic. And this is a well-known compound. It's a cyclic, planar, and all carbons are sp2 hybridized. Double bond is in conjugation, which double bond, single bond, double bond, single bond, double bond. So 2 plus 4, 2 plus 2 plus 2, totally 6 pi electrons are there, which means it is aromatic. In the next case, this carbon is sp3 hybridized, which makes the compound a non-planar one. That's why it is non-aromatic. In the next case, again, this carbon is sp3 hybridized. That's why again non-aromatic. Okay. Now, in this compound, the compound is a cyclic one and it is planar and this carbon has become sp2 hybridized, which means all atoms are lying on the same plane, and 2 plus 2, 6 pi electrons are there. 6 pi electrons, which means it satisfies 4n plus 2 pi electron rule. That's why it is aromatic. The next one is again compound is planar, and 2 plus 2 plus 2 plus 2, totally 8 pi electrons are there. It deviates a 4n plus 2 pi electron rule. That's why it is anti-aromatic. Okay. The next compound, in this compound there are two rings that are fused together, and it has totally 5 pi bonds, that is 10 pi electrons. All the atoms in this compound are sp2 hybridized, which means they lie on the same plane, and we have conjugation also, double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond, double bond. And since there are 10 pi electrons, it satisfies 4n plus 2 pi electron rule, so it is aromatic. Now here two rings are just joined together with a bond, with a single bond. The first ring is, I am going to call this as ring 1, and this is ring 2. In ring 1 I have 6 pi electrons, and it is a cyclic one, planar. All atoms are sp2 hybridized, and it is aromatic. The second ring has only one pi bond, and these carbons are sp3 hybridized, which means this molecule is a non-planar one. This ring is non-planar one. So the ring 2 is non-aromatic. But still, overall, when this non-aromatic ring is connected to an aromatic ring by a single bond, the whole compound will be called as aromatic, for the simple reason it is not a part of the ring, but it is in isolation. The second ring is in isolation with the first ring. That's why overall I need to call this compound as an aromatic one. The next case. Here I have a cyclic compound, and the double bonds are in conjugation. All atoms are planar. So double bond, single bond, double bond, single bond, pi electrons, lone pair of electrons, which means I need to call this as aromatic. And 6 pi electrons are there, so that's why it is aromatic. In the next case, the compound is cyclic and planar. There is double bond, single bond, double bond, single bond, double bond, and I have pi electrons, lone pair of electrons. But this lone pair of electrons is not necessary to construct a ring current inside the benzene ring. See here, inside the aromatic ring, inside the ring, because already I have 6 pi electrons, so it is aromatic only. But since the lone pair of electrons are localized on nitrogen, this compound is more basic than this one. Here the lone pair of electrons will be used to construct a ring current, okay, to become aromatic compound. That's why pyrrole is lesser in basicity than pyridine. Again, this compound is a cyclic one, and it is planar, and conjugation is there, double bond, single bond, double bond, single bond, pi electrons, lone pair of electrons, and 6 pi electrons are totally there. These electrons will be utilized to construct ring current, so it is aromatic. The next compound is a planar one, cyclic, and it has conjugation. See here, double bond, single bond, positive charge, single bond, double bond, single bond, lone pair of electrons. This lone pair will also be used to construct ring current. That's why it is aromatic. Now here the compound is cyclic, planar, and conjugation is there. Totally 10 pi electrons are there, so it satisfies 4n plus 2 pi electron. So we expect that this compound is aromatic. But to our surprise, it is non-aromatic. The reason is there are two hydrogens present here. These two hydrogens will start to interact with each other. To avoid repulsion, one hydrogen will go above the plane and another will go below the plane. And that's why the planarity gets disturbed, so it becomes non-planar, and that's why it is non-aromatic. Now the next compound. This compound is cyclic, planar, and conjugation is there. 10 pi electrons are there. So 2, 4, 6 and 2 negative charges are there. So we expect this compound to be aromatic. Again, this is an exception. This compound is non-aromatic because to avoid ring strain, this compound will take a different non-planar structure called bathtub structure. It will look like a bathtub structure. Conformations, it's another conformation. So this is a non-aromatic. Okay. This compound, 24th one, cyclic, compound is cyclic and some compound is planar one, and it has conjugation. Totally 14 pi electrons are there. That's why I will be calling this compound as 14 aniline. 14 aniline. And here again I have hydrogen here. These hydrogens. Okay. So these hydrogens again they will interact as in the previous case, as in this case, how they interact. Likewise, these four hydrogens will also interact in 14 aniline and will make the compound a non-planar one. That's why it is non-aromatic. The last case is 18 aniline. This is 18 aniline. And here I do have hydrogens, like here I have hydrogen, here I have hydrogen, here I have hydrogens, and here too I have hydrogen. So there are 6 hydrogen atoms. Here these hydrogens will not interact with each other because they are in a pi orbital which are at right angles to the extended pi system. So that's why this compound will remain as a planar one, and it satisfies all conditions for being aromatic. That's why it is aromatic. Thank you guys. Happy learning.